Hi, this is Sudeep and I welcome you back to this wonderful journey of learning structure analysis with StatPro. If you are new to this channel, I warmly welcome you. Please do hit the subscribe button and join us in this wonderful journey. And do press the bell icon for more notification from the Structural Insider channel. Now we have completed learning about the moment of inertia and the product of inertia. Today we'll discuss about transferring the moment of inertia from one set of centroidal axis to another. So let this be an arbitrary cross-sectional shape. Okay. Now, and let this be the centroid of that particular shape. Now, so far we have been sort of arbitrarily considering the centroidal axis as one being horizontal and one is vertical, right? So we were considering a centroidal axis sort of like this, where this is the horizontal centroidal axis and this is the vertical centroidal axis. But there can be infinite possibilities of a centroidal axis. For example, consider a centroidal axis like this and like this. So now this centroidal axis, this new centroidal axis, let it be represented as y dash and z dash, and this set of centroidal axis is or the angle of inclination of this set of centroidal axis from the horizontal and vertical centroidal axis is, say, theta. Now the question is, now of course, like as I've said, that the x-axis in this case would be pointing towards you, towards the camera. Now if you look at this diagram very carefully, you can see that there are these infinite possibilities between theta equal to 0 degree and theta equal to 360 degrees, right? So you can have infinite possibilities of this centroidal axis. Both yz and y dash and z dash qualifies to be a centroidal axis because it passes through the centroid. So now the question is, like, when we talk about a centroidal axis, what is it? Which axis should we consider in the first place? Because horizontal and vertical centroidal axis, as we had been considering, is also a reference, right? Based on how you are looking at the figure, the definition of horizontal and vertical could change, right? So the point here is that you can have multiple sets of centroidal axis, right? Now one of the things is that say we know the moment of inertia and the product of inertia about one set of centroidal axis. So let us say that we know the moment of inertia Iz of this cross section, Iy of this cross section, and Iyz. So this is the moment of inertia about z, this is the moment of inertia about y, and this is the moment of inertia about, or rather this is the product of inertia about this set of axes yz. Now the question is, if we know this, can we calculate the moment of inertia or the product of inertia about this new centroidal axis y dash and z dash? Now we will see that now. So we have this cross-sectional area as we have drawn on the board. So y and z are one set of centroidal axis about which we know the values of the moment of inertia and the product of inertia. And let us consider another set of centroidal axis yz dash z dash inclined to the previous set of centroidal axis by an angle theta. Now let us consider a point or an infinitesimal area dA in this whole cross section. Now, so in this case, the distance of dA from the original axis system, that's not horizontal, from the original axis system, y and z be given by, so these are capital Y, right, it indicating the axis. Now, okay, so this is the distance of the infinitesimal area dA from the vertical centroidal axis, and this is given by distance z. And because it is measured parallel to the z-axis. Now, similarly, the distance of dA from the inclined y dash axis would be given by z dash, which would be parallel to this z dash axis, right? These are small values, small letters. Now, in the same breath, we consider the vertical distance to the z axis measured parallel to y. So this would be y, and the distance of dA parallel to this y dash axis or perpendicular to this So we are trying to find out what we try and do is we try and express this y dash and z dash, the distance from the new axis system, in terms of the distances of the old axis system. Okay, now we need to do a small construction here. So let us extend this line and let us drop a perpendicular from this line to this particular point. So this is 90 degrees, right? And now from this line we drop a perpendicular to this particular y dash axis. Now let us name the points as, let us name this point as P, and let us name this point as Q, let us name this point as R, let us name this point as S. Okay, now consider this triangle. Now this is the centroid, let us represent that as C. Now we'll do a bit of geometry here. So in triangle CPQ, now this is a perpendicular, right? So this is a right angle triangle. So CPQ is a right angle triangle. So in triangle CPQ, we have CP would be equal to CQ into cos theta, right? It would be, because this is a right angle triangle, so CP by CQ would be cos theta. So CP would be equal to CQ cos theta. And what is CQ? CQ is nothing but the value of, because CQ is equal to this distance, right? So CQ would be equal to y. So CP can be represented as y cos theta. Now let us, in this particular triangle here, again let us consider this one. So let us say this point of dA is N. So in this is also a right angle triangle because the angle here is 90 degrees, right? So this is a right angle triangle. So then we'll have in triangle NRQ, we have RQ, right? This value RQ would be equal to what? Now see, in this triangle, this, now since this is inclined by an angle theta, the perpendicular distance to this line would be inclined by an angle theta from this line. So this angle in the right angle triangle would be 90 degree minus theta, right? So that would mean that RQ by NQ. So of course, if this is the right angle triangle, this is the hypotenuse. So this would be base by hypotenuse. That would be cos theta. So we'll have RQ as NQ cos theta, or 90 minus theta, because this angle is 90 minus theta. So NQ is nothing but, what is NQ? The value of NQ is equal to this value, or Z. NQ is nothing but the Z, this value Z. So it would be Z, and what would be cos 90 minus theta? It would be nothing but sin theta. Right. So in this case, now let us consider this complete line. Now RQ, now since this is a rectangle, right? This is a rectangle. RQ would be equal to PS. Now RQ is equal to PS, right? So therefore this would mean that PS will be equal to Z sin theta. So we have this total line CS. What is CS? CS is nothing but Y dash. So CS equal to Y dash, and CS would be equal to CP plus PS. So this would be equal to CP plus PS. CP is what? Y cos theta. And what is PS? PS is Z sin theta. So we have converted, we have expressed the value of Y dash, that is the distance, the distance of this area dA from the Z dash axis in terms of the distances that was expressed against the original set of axis system Y and Z. So we have Y dash equal to Y cos theta plus Z sin theta. So let us write this, whatever we have found here, down in here. So Y dash comes as Y cos theta plus Z sin theta. Okay. Now let me wipe this off and we'll retain this result here. Okay. Y dash or rather Y dash equal to Y cos theta plus Z sin theta. So as we have derived, Y dash equal to Y cos theta plus Z sin theta. Now we have to find out Z dash, that is this value, in the same terms. Now let us, in this triangle again, NRQ, this NR is the perpendicular, so it will be equal to Z of sine 90 degree minus theta. So that will be equal to Z cos theta. Again, in this triangle CPQ, right, CPQ, we have PQ equal to, this is again, now if this is theta, this would be the perpendicular and this is the hypotenuse, right? So it would be CQ sine theta. So what is PQ? PQ is nothing but, this is a rectangle, right? So PQ is nothing but SR. So that would mean SR is equal to, what is CQ here? CQ is nothing but the value of Y, or so this would be Y sine theta. So now we have Z dash will be equal to NR minus RS or SR. So this would be NR minus RS. NR is what? Z cos theta. And RS is what? Y sin theta. So we have got another term that, so Y dash, which is the distance of this infinitesimal area dA from Z dash axis is expressed as Y cos theta plus Z sin theta. Similarly, the distance of this infinitesimal area dA from the Y dash axis is given in terms of Z and Y, Z cos theta minus Y sin theta. So Z dash will be equal to Z cos theta minus Y sin theta. Okay, now we will be using these two values in our deductions as we go on. So we retain these values, and I rub off this how we had calculated the same, but we have now proved that Y dash equal to Y cos sin theta plus Z sin theta, Z dash equal to Z cos theta minus Y sin theta. Now in our calculation, so what do we intend to find? Now what are the values that we know? The values, known values are, we know the value of this cross section, the moment of inertia of this cross section about the Z axis. We know the moment of inertia of this cross section about the Y axis, and we also know the product of inertia of about this set of axes I, Y, Z. Now we intend to find from these values and this inclination, the angle of inclination theta, we intend to find the value of, objective is to find the value of IZ dash, so about this new cross section, new axis system, and IY dash Z dash. How can we do that? Now, so this is the objective. Now there are, we want to use two trigonometric identities here, right? So I'll write that down. You can find the proof of this in any standard trigonometry book. So you can go, so cos squared theta I'll express as 1 plus cos 2 theta by 2, and I will use sin squared theta as one minus cos 2 theta by 2. Now for IY dash, so we want to calculate the value of IZ dash. So remember what our formula would be? For IZ dash, the distance of this infinitesimal area dA from Z dash axis is Y dash. So IZ dash would be nothing but Y dash square dA. And what is Y dash? Y dash is nothing but Y cos theta plus Z sin theta. So we express this as so if we break this up, it would be just using the standard integration rules. Right? So now one of the things that you understand here is that we are finding this out for a fixed y dash and z dash axis. So our theta in this case is constant. So we can actually take out the cos squared theta. So like this, and it would be nothing but y squared dA plus 2 cos theta sin theta. So it will be yz dA plus, if we so this would also come out, sin squared theta would come out, so we'll have z squared dA. Now what is this y squared dA? It's nothing but the integration of y squared dA is nothing but the moment of inertia of this whole cross-sectional area about the z-axis, right? So then this would be Iz cos squared theta. And what would be the value of this one? This is the product of inertia. So of about the yz axis set, right? So then we'll have we'll have Iyz into 2 cos theta sin theta. And what is this integration here? It's nothing but the moment of inertia about the y-axis, this axis, right? So then we'll have Iy sin squared theta. So then if we go forward, what is cos squared theta? Well, cos squared theta is nothing but, there is one trigonometric identity that I didn't write here, but anyway, so we can actually write this as cos squared theta is 1 plus cos 2 theta by 2 plus sin squared theta is 1 minus cos 2 theta by 2. So I write Iy 1 minus cos 2 theta by 2, and finally Iyz. Now what I didn't write is 2 cos theta sin theta is equal to sin 2 theta. Okay, this is another trigonometric identity that we will use. So sin 2 theta. So we have now calculated the value or the moment of inertia about the z axis from the known values of Iz, Iy and Iyz. So this is the moment of inertia about the z-axis. So it is seen that if we know the moment of inertia and the product of inertia about a centroidal axis, we can calculate the moment of inertia about a transformed axis which is inclined at an angle from the original axis system. Of course, we have only found out the value of Iz dash. In the same way, we can find out the value of Iy dash. So let us write this down. Let us retain what we have found here as, so these values are something that is now obvious. So I will just remove this now to note down the value of transformed moment of inertia. So we have found that Iz dash is equal to Iz 1 plus cos 2 theta by 2 plus Iy 1 minus cos 2 by 2 and Iyz sine 2 theta. So this is the value of Iz dash. So this value, before we go into the calculation of Iy dash, this can be expressed as, so if you actually rearrange these terms, we could express this as Iz plus Iy by 2, and then we have Iz minus Iy by 2 plus Iyz sine 2 theta. Now, it's not important to remember the deduction or these formulas, but what I'm trying to go, it's very important to have a sense of how the things comes, and that's why I'm giving you these deductions. So even if you do not need to know this by heart, at least it would be good to get an idea of how things are happening, because we will lead this to the concept of principal axis system, which would be related directly into what we do in Stat Pro. Now, let us go for the calculation of Iy dash, right? Calculation of Iy dash. In the same manner, Iy dash would not be nothing but the, so this would be, for this infinitesimal area, it would be the second moment about the y dash axis. So the distance is z dash, so z square dA, and for the whole cross section area we will do an integration, and for z dash we again have, so integration of z cos theta minus y sin theta whole square dA, right? So if we actually rearrange the terms, we will get, so basically it's the same calculation that we have to go through. So I won't go to the details this time, but what you will get here would be Iy cos squared theta plus Iz sin squared theta, and you will end up with, so this is the calculation would be similar to what we did in the previous, but you try that out yourself, and in case you are not able to solve or come to this value, let me know and I can show you the detailed calculations. But I have skipped a few steps here because this is exactly the same as what we had done in our last deduction for the calculation of Iyz. And so cos squared theta, again it comes as 1 plus cos 2 theta by 2 plus Iz is sin squared theta would come as 1 minus cos 2 theta by 2, and finally we have this as minus Iyz sin 2 theta, and rearranging the terms, what we'll get is Iz plus Iy by 2. Again, I'm saying that it's not important to remember the deduction. That's not important. What is important is that you need to appreciate that there is a relationship between the moment of inertia about one set of centroidal axis and the other, and you just need to be aware of that relationship. So we can, rearranging this term, we can get cos 2 theta minus so this is the calculation of Iyz. So we can actually now then write what we have found out here. So Iy dash thus would be equal to Iz plus Iy by 2. In this case we have plus Iz minus Iy by 2 cos 2 theta. In this case we have minus Iz minus Iy by 2 cos 2 theta and theta and minus Iyz sin 2 theta. So now we'll do our final calculation of the product of inertia about this new set of centroidal axis, and we know that this would be nothing but y dash z dash into dA. Now we'll do a full calculation here once again because it's not similar to what we have done before. So what is y dash? Again, y dash is y cos theta plus z sin theta. So put that down. What is z dash? Z cos theta minus y sin theta. Sorry. Z cos theta minus y sin theta dA. So rearranging the terms again, we'll have, so this one theta is constant, so y z cos square theta, so cos square theta would come out and we have yz dA, right? And then we have y cos theta into minus y sin theta, so we have minus sin theta cos theta, and then we have y square dA, and then we have same thing plus sin theta cos theta z square dA, and finally we have minus yz sin square theta. So we have minus sin square theta integration of yz dA. So you can see that these two terms, you can rearrange this in two terms. So we have cos square theta minus sin square theta into y. What would be this integration of yz dA? It is the product of inertia Iyz, right? We know this value. So Iyz, and then we have, this one is nothing but the moment of inertia Iz. So we have now sin theta cos theta. Okay, now we can have this value as so this one y square dA, right? Sin theta cos theta would be, so this is Iz, so we have sin theta, sorry about that. So we have, this one is Iz, so Iz sin theta cos theta, and this one is Iy sin theta cos theta. Now cos square theta and sin square theta can be expressed as cos 2 theta, right? Because cos 2 theta means cos theta plus theta, which would mean cos theta minus sin theta sin theta, so that will come as cos square theta sin square theta. So that would mean that this one would be Iyz cos 2 theta, and then now if we actually take the value of Iz minus Iy, right? So basically then we have, so if I take minus here, then it would be Iz minus Iy sin theta cos theta, and that would mean that this one would be, if I actually take a division by 2 and multiply this by 2, then this would become equal to by 2, and 2 sin theta cos theta would mean this is sin 2 theta plus Iyz cos 2 theta. So this is our product of inertia that we want to find out. So let us retain these terms here, Now that we have calculated, our objective was to calculate iz dash, iy dash and iy dash z dash from the given values of iz, iy and iyz. So thus iyz can be expressed as, thus you can express is equal to minus iz minus iy by 2 sine 2 theta and plus iyz cos 2 theta. In case anything is unclear, please mention that in the comment section below and I can clarify that to you. Okay, lastly we'll discuss about a very important relationship. So we know what iy dash is by now, we know what iz dash is by now, and we represent those expressions in terms or in by the names of equation 1 and equation 2. And if we add up equation 1 and equation 2, which would mean adding up iy dash and iz dash, we see that that is equivalent to iy plus iz. This means that if we have a set of centroidal axes, the sum of the moment of inertias about both the axes would be equal to the sum of the moment of inertias of any other set of centroidal axes. And how do we come to this conclusion? Well, you could see that this term should cancel out and these two terms would cancel out, and this would leave us with iz plus iy by 2 into 2, which gives iy plus iz. So I hope you understand this concept. So now we understand that there can be many possible sets of centroidal axes of a particular cross section. If we know the moment of inertias about one particular set of centroidal axes, we can derive the moment of inertias about the other sets of centroidal axes too, provided that we know the angle of inclination of the later centroidal axis with the former centroidal axis. But which among these multiple sets of centroidal axes is important to us? Well, we'll see that in the next session. If you have liked this video or if you think I have added value, please do consider hitting the like button so that this video reaches out to many others who would be requiring this content. See you in the next session. Till then, bye.